What?
Yeah.
Yeah.
It's funny. No matter what I do,
Of course they should.
it's like the most terrible feedback noise ever. They're like, why does it say?
What was your experience with that?
Oh. Also, I used some time.
Okay.
No, you can hear
Sorry,
how
crowd
it
appropriate.
worked twice.
Oh, okay.
Here.
Story.
It's so crazy. I was in the middle of writing Alex and telling him, hey, I'm nearby external migration.
You used WordPress to build the site. And so,
That's not what happened. That's not what happened.
The real question is it static WordPress?
Frustrated myself to death and finally figured out a solution. That's how it worked.
What is static WordPress?
It's almost right.
In other words, it's not serving off a database. Like, that's the number. Like, you can like generate it. You've heard of like Jekyll or OctoPress. It like generates it, it's just static pages. It makes it a lot less likely that it'll get hacked. And even like a source of malware. Because I mean, like all these WordPress sites are very, you're not completely up to date. There couldn't be an exploit, and then there's your bot. So look for that exploit. And the next thing you know, you're lost. It's at least hit and check your
No.
email. Every, like, now.
All right, it's 6 o'clock, so we might get started. I do hope Maiwa will be here later with his colleague Dave, who's actually going to teach a guest lesson today if they arrive, which is what we have the second half of the class planned for. If something has gone wrong, then I'm sure we can figure out something else. So, but the plan for today is to finish up our higher orders material from last week. We're going to go over 2 examples of writing higher order functions, so you can get to see what a higher order function is doing and how it behaves. That will give you a better understanding of how to use them, but also give you an opportunity to write them. And in fact, our homework assignment for this evening involves writing a couple of higher order functions. And then I'm going to give you a very brief introduction to object-oriented programming. Very brief, that does not really touch at all on how JavaScript really does it under the hood. I'm almost not really qualified to do that, or at least Dave, hopefully, who will be here, knows how to do it way better than I do, which is why it's great for him to come and give that lecture. But I can do an intro to it, and then we can confuse you guys afterwards, so because it is confusing. Do we have any announcements? Anything going on? Announcements? Class-related? Prototech meetings? People hanging out? I see pictures. I saw pictures of you guys. Yeah. I saw pictures of you. Yeah. So, were you guys working on this stuff, or you were just hanging out? Cool. So, what was that in? Where did I see that?
OKC Midtowner.
Yeah. Okay, the Midtowner. Yeah. So, cool. I'll do office hours on Wednesday. So even if no one's there, I still do work, so it's quite all right. But 11:30 to 1:30 at Camps 1910 on 10th Street, just off of 235. Anything else going on? I'm keeping an eye out for other user group meetings and things like that, but
there's a WordPress meeting tonight, but
yeah, so cool. So this will be our last lesson on just learning how to use JavaScript, really on JavaScript the language. Starting on Wednesday, we're going to get back into Node and Express, and we're going to figure out what in the world those tools do that we've had been using the first couple of weeks without maybe really understanding them because they're written in JavaScript. So now we have the framework for going back and looking at that code and going, oh, this is how it works. And at that point, we'll do a day of that, and then we're going to get into building our web application for the rest of the period. So we've done kind of 5 weeks of introductory orientation material necessary to learn the basics. And then we're going to jump into applying all of that stuff at the exact same time as we actually build a web application. And down the road, we'll learn how to use databases and be introduced to a few more technologies as well. But if it's starting to feel a little boring or seems like it had slowed down or was a little too theoretical, probably it hasn't slowed down, but if it were a little too theoretical, we start building stuff on Wednesday. So, okay, so let's wrap up 2 higher order functions. So I'm looking at the JS Advanced Functions class material here, which is the third one down from our OKCoders GitHub. And it's under functionalprogramming.md, and it's towards the bottom. This is a huge document, but it is this section right here, 2 higher order functions. So we've been talking about higher order functions to jog your memory in case you'd forgotten. These are functions that take functions as arguments and then can call those functions, right? And so we had an example where, or did we have an example? We had one where returned a function, where we generated a function based on creating a power of something, and we called it square or cube. So we're going to do something along those lines, except for using functional arguments instead of returning functions. So we're going to start off with is a really common example of a higher order function. It is a for each function. So I'm going to open I'm going to create a test document. So I'm just in a directory somewhere, and I'm going to touch test.js so that I can execute it with Node. So I could do node test.js, and obviously it's an empty file, so it doesn't do anything. But this is where I'm going to write my code. It's a little too much code just to write inside of the Node REPL. So, and then you want to view that file in Sublime, however you are accustomed to doing that. So I use the subl command on the Mac. Otherwise, you got to open that file up in a directory somewhere. So, and let's make that a bit larger so we can see it. All right. So developers, if you've looked over this assignment, have a problem. Looping over arrays is a little annoying. It's a lot of syntax, and if you're not familiar with for loops, it's a little, it can be excessive syntax and easy to confuse. So you can imagine having an array that contains a bunch of elements like the integers 0 through 9, and you want to just go through every one of those elements and print them to the console or do something with them, right? So you'd write a for loop. Say for, and then in parentheses, var I is equal to 0. So it's going to count, this I is going to represent the index of each element in the array. I is less than array.length. And semicolons between all of those, right? And then I++, which is a shortcut for I equals I plus 1. Or, excuse me, I plus 1, like that. It's a common shortcut for that. Okay? And now I've got the index I for possibly each element in this array. I need to get each item in the array, so I could say var item equals array at index I, and I use that square bracket notation, right? And then I can do something with the item. So I could do, say, console.log item. And it doesn't really matter what we're doing in here. That's not the point. The point is this for loop structure, right? So I could save that, just a for loop, and then run it in Node. And obviously, it goes through each element in the array and prints it. It's totally expected, no big deal, right? Writing a for loop is a little annoying. Like I say, there's a lot of syntax, but more interestingly, and maybe more importantly, we're doing the exact same thing every time we write the for loop. Every time. So you can imagine that there's this pattern that we want to abstract out of what we're doing with our code here. And the pattern is creating a new variable, setting it to 0, iterating through that variable one integer at a time, all the way up to the length of some array, getting the item from that array, and then doing something with that item, right? Every time you do a for loop, that is what you're going to do. What if we took that functionality, that pattern, and stuck it inside of a function? That is what functions are for. Functions are for reusable blocks of code. We want to take something that we do a lot and stick it in the function. The trouble is, though, normally with functions, the bit of information that we can add to it comes in the form of just some simple data, a variable, right? So maybe the array. I could pass the array to the function, and then the function could do something with the array. But I need to do something more here. I'm doing console.log item in this case, but I could be doing anything. I have a bunch of code that you could think of as its own sort of block, and I can just stick curly braces like that. And there's a bunch of code here, maybe 1,000 lines of code, and that is what I want to do. And that can be different in every case. So we look at what's similar is the fact that we're going through a for loop, and then what's different, the fact that I'm doing something with the items in that array. And we ask ourselves, well, how can I implement that with a function? That is what a higher order function lets us do. We can encapsulate code, the custom bit of code that we want to use every time in a separate function, and pass that function to our for loop function. And then our for loop function is going to do what every for loop does, and then call that block of code for each item in the array, right? And I hope, like, is it clear how that's different from just passing in a simple variable? We don't just want to say 10 or hello or okay coders. We want to actually do something. And that is what passing a function into a higher order function lets us do. So let's see what that looks like. I think this one is pretty straightforward. But again, it's a particular way of thinking about the problem. So, all right, let's build this thing up piece by piece, which is how I've got it laid out in this document. So I want a function. I know that I want a function that is going to be a for loop. Let's call it the for each function, which is a common name for this. And so we start really simple. I've got a function, it's the for each function. That's it, nothing else. What does this for each function do? Or more importantly, what parameters does it need? Let's start with that.
Array.
We need an array, absolutely. So let's say we got an array coming to this thing. And then what's the other thing that we need?
Action.
The action, whatever the action is. Basically, whatever this block of code is going to happen to be. So that'll be our callback, right? That's going to be the function that our higher order function calls. And I like action for that word. In the documentation, I call it a callback, but I think action is a good one, because we're basically saying, here, do this with this item. Okay? All right, so now what does our function for each do? So what does it actually do? Well, the first thing it's going to do, and I'm just giving myself some space so I can keep it up at the top, our function for each has got to run through a loop, right? So let's go ahead and write that in there. This is the exact same code that I'm using above, iterating over this array instead of some global array, right? So I can do the same thing. I write a for loop. For var I equals 0, colon, or semicolon, or I is less than array.length, semicolon, I plus plus, and then curly braces, right? So we know we're going to do that. Fantastic. We also know that inside this for loop, we want to give action the chance to do something with one of these items, right? Specifically with whatever item our index represents at the moment. So we know that every time through that for loop, we're going to call action. Remember, action is our function, yeah? But we need to give action something. So what is the function action going to look like? What if I had a function I was applying to this? So I could say function, my action. It's not just going to be an empty function. It's going to be a function that takes an item, namely the item at the current index in the loop, yeah? And so we need to pass the item to action when we call it. Where do we get the item from? Well, it's basically this thing right here. It's the item at that index in the array. So I can say var item equals array I. And I'm calling action. And that, right there, is the whole function. That's it. So we just wrote a higher order function that encapsulates the pattern of looping through an array, but will now let us do that without having to write a for loop every single time. Let's simplify this a little bit more, and then I'll show you how to use it. Notice that we are simply getting array I, storing it in a variable, and then using that variable right away without doing anything else with it. Well, we don't really need to store it in a variable then. Let's just go ahead and grab it and immediately do something with it. So I can take item. Item is array at I. So I'm going to cut that out, and I'm going to replace item with it. And then now I don't need to use that local variable, right? Effectively, this doesn't have any like, or there's no effect in the underlying implementation on your code. Like, it doesn't make it more memory better or whatever. Like, things still have to get pushed around in memory and stuck on registers in the processor. But it's a little cleaner. Yeah. Okay, so we've got this for each function. How am I going to use this? Well, let's keep using my array up here. So I'm just going to copy and paste this back down here. I could define. Let's go ahead and define my action that I'm going to use. And again, I'm just going to go console.log on item. So now let's call for each over this array with my action as the function it should do. So now instead of writing a for loop and writing out that var I equals 0, I is less than length and all of that stuff, I just call a function. Call for each with the array in my action. For each gets called with that array. It's going to loop through every item in the array, and then each time through the loop, it's going to call action with that item. an action here is my action. That's the argument that I'm passing. And so this function is going to get called for every item through the loop. That is like a canonical example of a higher order function. Does that control flow make sense? So let's see it in action. I can comment out the stuff that I had up here, confirm that it's not actually being used, and then run the code. And we see that we get the exact same result, right? Now we've learned about anonymous inline functions. So if my action, if the only time I'm using this function is to deal with this for loop right here, with this call to for each rather, then I don't really need to define a function my action if I'm only using it once. Yeah? If I'm only using it once, I might as well just drop it right in here. So how do we do that? I can take this code, cut it out, replace my action with it, and then this is a function that is anonymous. It shouldn't have a name, so I can just delete its name. And this is identical to what we had just written above, except for now, instead of explicitly defining our function, we use it inline with for each, and it will only exist as long as our for each function is being called. But otherwise, it's effectively the exact same thing. Yeah?
Question. So no space between function and the parameter.
Doesn't matter.
Okay.
So the spacing is not significant there.
Okay. Thank you.
And remember, what we're doing with each item, that's what changes every time. So in this example, we've got console log, but I could actually do var age in 1 year equals item plus 1 times 10, who knows, right? And then I'd have to put that in parentheses, so that's actually item in, I don't know, a decade, whatever, and then I could console log that, or I could pass it to some other function, or I could do whatever what I want with it. The whole point is we've encapsulated this stuff inside of that. And it's a bit easier to use. So now it'll be, it'll do something like that. Right? I think this is pretty cool. Once you get your head wrapped around this, you're going to see all kinds of opportunities for thinking in terms of writing your code this way. The basic problem that we're trying to solve here is that we have an algorithm. And an algorithm is nothing spectacular, right? It's a fancy-sounding word. An algorithm is just a sequence of instructions that can be followed in a mathematical way, so a precise set of instructions to a computer. Looping over an array is an algorithm. Doing something with an item is part of that algorithm. And so in like all functions, we're always going to have some algorithm. And that algorithm is going to have a structure. It's going to have some kind of form where it always does this, and then it always does this stuff down here. But in between, something's going to be a little bit different every time. And sometimes what's going to be different is just going to be some variable value. So we might need to pass in the number 10, or we might want to pass in the number 20 instead. And so our algorithm will take a parameter x, and somewhere in the algorithm it'll use x, right? And so like giving a person's age in a year is an algorithm that adds 1 to the person's age. So all we need is the person's age, right? But other times our algorithm is going to be more complex, and what happens inside here is going to have to be an actual block of code. So we're going to have to do something else. And so we need a way for our algorithm to give information to this block of code, and possibly for this block of code to return information back to our algorithm. And so now instead of using x, we use some kind of function. And our algorithm will call function, perhaps with some data, and use the result of that call. But it's the exact same problem that we're trying to deal with. We have a generic solution, but at some point in that generic solution, we need to have more specific functionality that will be different for each case. And as the programmer, we get to define that use case while taking advantage or leveraging the generality of the algorithm, right? And so this is just a common solution to a problem, which is how do we keep the general while allowing for the specific? Okay? And higher order functions, and I think encapsulate that wonderfully. So they're a great solution to the problem. Okay, now I included this in the repository, so this example code here, in addition to being present inside of this document, and I think shown in its entirety at some point, and how to use it, is also available. I'm going to go back here, in this foreach.js guy right here. So you can always refer back to this to see what it was that we wrote. Yeah, this is the code right here. So, all right, let's do map. This one's even more exciting. So map is like, hey, what's up? Map is like the classic functional function, right? Map solves a particular problem. We'll have a series of data in some kind of format, and we want to transform that data into possibly some other format, but we need to do the exact same thing to that data every time. And the point is, we're going to have a list of data, an array of data. We want to run over each one of the items in that array, do something with that, collect the result of whatever we did, and then return a new array that contains whatever transformation we applied. And so we're really just basically applying a function, say f of x, to an array of items, one at a time, each one going into x, spitting out some value, so we'll get y back, and then collecting all of the y's inside of a new array, right, and returning that array. And so you can imagine, let's say I have a list of objects. So we know we have lists, we've got arrays, we know we have objects, and they're people objects. And so like I have a list of 10 people. And each person object has a first name, a last name, an age, and a city. And I want to extract all of the ages outside of these objects. So normally I would write a for loop that goes over each one of those guys, grabs each age, sticks it in its own array, and then returns that array from that for loop. Or it's like basically I'm pulling the ages out of these objects. Yeah, I want to discard everything else. I just want the ages. Well, this general pattern of going over the for loop, looking at each item one at a time, pulling something out of it, possibly transforming it, storing that in the array, and then using that array again, is similar to the general pattern in our for each loop that we extracted. We need to do that every single time we want to map, but what we do in the map will be different. The transformation itself will be different. And that transformation will be code. It won't just be a variable. And so we're going to write another higher order function that will abstract out this common pattern while still allowing us to do the specific detail of extracting and transforming the data. That is called a map. Let's see what that looks like. And so I guess I had an example. I'm going to blow out this for each stuff. So I had an example of ages. So let's say we've got an array of our ages, say 21, 33, 13, 45, 62, and so forth. And I want to know the age of all of these in 1 year. And I want to store that in another array. So I could say ages next year is an empty array. And then I'm going to write a for loop. Var equals var I equals 0. I is less than ages dot length. I plus plus. Yeah. And then I'll go okay, var next year equals, let's just start with the item so we can see every step. Var age equals ages at I. Next year equals age plus 1. And I want to store that in ages next year. I can refer to I because it'll be the right index every time, equals next year, and so on. And then I could console.log ages and say console.log ages next year. And we'll see that I start off with my array of ages, and I end up with an array of ages plus 1. This is my transformation. My transformation is add 1 to each item in the array. And just to say it again, this pattern of looping over the array, getting each item, doing something with each item, and then sticking that thing back in a new array is this exact same pattern that we need to use every time. What's different is this process right here, what we actually do with that item. That might be very different every single time, right? So let's encapsulate this inside of a higher order function. Our function is going to be called map. So let's go ahead and template it. What is map going to take? An array. So we know we need an array. And what else?
Callback.
Our callback, an action, right? Whatever it is that bit of code is going to do, this age plus 1 stuff. Okay. And just like our for each loop, it's going to iterate over that array. So we could say for var I equals 0. I is less than array dot length, I plus plus. We know that I'm going to need to do something with each element in that array, so I might as well go ahead and grab it. Var item equals array at I. Okay. And then I'm going to, just like in our for each function, I'm going to call action for every item in the array. That's just for each right there. Yeah. So what else do we need to do? We need to collect the results of applying this action in another array and then return that array. Yeah. So outside of my for loop, let me create a new array. Var new array equals just an empty array like that. And I'm going to return that when I'm finished. So again, outside of my for loop, I'm going to return new array. And then now, this action function, whatever it is, say age plus 1, is going to return a value. I know that. That's the contract that this function says, that or establishes with its callback. It says, hey, callback, you must return something. I could get the result of that, var result, like that, and then add that to the new array. So now, for every item inside of array, grab it, call action with it. Whatever action is going to return some result. Stick result in this new empty array that we started up here, and then return that new array when we're done. Yeah? And this is the exact same thing that we're doing up here, except for action now takes the place of that. Yeah? Otherwise, it's identical practically. Right? So now we've abstracted this pattern that we would have to rewrite every time we wanted to do this, and can call map and provide the action that we want. So let's see how to do that with our ages. I can call map on ages, and then I'll go ahead and write my anonymous inline function right here. So I say function. My function is going to take an item. That's going to be this guy right here, right? This is our action. Make sure we get my syntax right. And then from inside this function, and this is where the syntax looks a little bit trickier, I need to return a value. And remember, I'm not returning from map. I'm returning from this guy right here, my anonymous function. So I can say return. I know that item is going to be a number, item plus 1. Yeah? And then this guy that's returned is going to be this result right here. It's going to get added to new array, and then map itself is going to return new array. So this whole function is going to return a value. And I want to collect that. So I should say var new ages equals the result of calling map. Yeah? But be careful, what looks tricky here is that you might think, oh, I'm just returning item plus 1, and that is what gets stuck in new ages. No, this return statement belongs to this function, which is having its action right here. And this result equals action item. I have to remember that when I'm doing this and pointing at this, I'm not pointing at that, and it's getting my screen. So, and this right here, say, I mean, it might be, you might be like, why would we do this with for each? Hold on just a sec. But now we can see that I've got 3 lines of code, whereas before I would have needed like, well, that many lines of code every time I wanted to do this. So I've saved on code, and I've got a general pattern that I can reuse. Yeah?
I'm just going to sort of rephrase it to see if I do understand it properly.
Okay.
So the output of map is whatever new array.
That's right.
That is created after you is created based off of the alteration that you want to happen to an array that you pass.
That's right.
And then all that you said equals to sort of like the name of whatever.
Yeah, the new variable. Exactly right. Yep. So I need to do something to every item inside of an array and collect the results of doing that something. And then I want to go do something else with those results, right? And so now that we've got this like map code here, we could like hide it away. So we could stick it way down at the bottom of our file so they don't see it. And now I can do many things that I want. So I could say var ages in 10 equals map ages function item, and now I want to return item plus 10, right? I get to do a different thing every time now, but the general pattern of iterating over an array, doing something with each item and collecting those results stays the same, yeah? So map takes care of this, and our function callback or our action is the extra bit that we want to do for each thing, yeah? I love this stuff. I think this is the coolest thing about JavaScript right here. And this is extraordinarily practical. So what we're going to find out is inside of all of the asynchronous, and that's a call, so I should end it with a, or statement, end it with a semicolon. Inside of all of JavaScript's asynchronous like connections to databases and reading files, basically everything that we do in Node and Express, we need to provide callbacks for, because they're going to happen out of time, and they won't happen in a linear fashion. And so we're going to see the use of this pattern where we have to give a function to a higher order function and then do something when that function gets called every single time that we do anything in Node or Express. Yeah. So we definitely want to make sure, even if map is, we're uncertain about how that works, that we get the fact that we can use higher order functions. And I think these are just two fantastic examples of that. And so let's go ahead and console.log this stuff, just so that we can see the fact. Save that, run it. So we start with ages. We end up with ages plus 1, and we end up with ages plus 10. Yeah. The more interesting things that you can do with this stuff, and I think I might even have included an example in here, which we could run through real quick. Oh yeah, let's totally do this example. This one is much more exciting. Okay, does this make sense? Any questions about this? Okay, nope. It doesn't make sense, or no questions? Like, oh my god. So it took me a while to get functional programming. This was definitely a new way of thinking about things, especially if you're taught object-oriented programming in a computer science curriculum. Yeah.
Is all like what of this stuff when writing a new program you rewrite versus what used to be available?
Right. So map right here is not built into Node, but it is included in JavaScript. Yeah. For each is. I don't think map is now, because I mean we could always check. So I should be able to start up Node and then see if I can call map. Map is not defined, so map is not in here. For each, nope, for each is not inside of Node either. So it's part of the new JavaScript specification. So most browsers implement for each now, but apparently map is not implemented. However, what we're going to learn is that there are libraries. So these third-party codes, libraries like Express, that implement this stuff for us, and we can import their code into our program and use it without having to rewrite it. The really popular one that encapsulates a bunch of this functionality and some more stuff that is used in client-side programming, so for programming in a web browser. You'll see this in jQuery, which we will go over at some point in our class in a later lesson when we move back into programming on the browser. But jQuery implements a few of these, and underscore, so _js.org implements all of these guys. So like map, select, invoke, and so on. So we will definitely see how we can use other people's code rather than writing our own code to do this. But what they're writing is basically exactly what we wrote here. It's no different. Yeah. They're on the prototype? Oh, cool. So you can call map on array? Sweet. Yeah, you got to give it a function and stuff, but cool. So, and we haven't learned quite about object-oriented programming yet, but we have a sweet segue into that for this afternoon. So, so we'll, after Dave, right? Dave, yes? Did I get it right? Yes. Adam, damn it, why do I keep on... I'm like, no, Adam. And I was like, I wanted to double check my email. I was like, no, I got it. I remembered. I did not. So when Adam gives his lesson, then we can segue back into this and see how we can take advantage of the built-in functionality rather than writing our own code. So that'll be perfect. So, okay. Let's see a more interesting example of this. Let's see a more complex transformation rather than just adding one to an item. So let's delete that stuff here. We're going to keep our map function. We're going to get rid of ages, and let's do this person one. So I've got var people is going to be an array of objects. So I'm going to have a bunch of objects. I'll do 3. And then inside of each object, I'm going to go ahead and give them a name. So we'll say Mark, and an age, name, and name foobar. That's what I'll name my kid. Age 31. Okay. So I've got a bunch of people with names and ages. I want to extract the age out of each of these and stick that in a new array. So I can call map on my people, give it a function. That function needs to take an item. It's going to be each person. I could even call it that. I could say item. I'm going to call it a person. And from each person, I want to return person.age. So the effect of this data transformation is to turn a bunch of objects into a bunch of numbers. I'm going to start with an array of objects. I'm going to end up with an array of numbers. And then I can collect that var result equals map, and then do console.log people, console.log result. Right? But notice what I can do. That transformation is just basically me inserting a single line of code inside of that function. And if I'm really feeling amazing, I could stick it all in one line. All of that reduces readability. So is it clear what's going on here? We're iterating through people. So each one of these objects is going to be passed one at a time to our anonymous function. And then I'm going to return whatever that object is .age. Yeah? So I'm going to get 39. I'm going to get 45, and I'm going to get 31. And then the map function is going to stick each of those numbers inside of new array and return new array. Yeah? So when I run it, I start off with an array of objects. I end up with an array of numbers. And effectively, in a single line of code, I'm able to transform a much more complex data structure into a simpler one. Yeah, it's pretty powerful stuff. Map is super powerful. And it turns out that you can implement this function concurrently across thousands of machines at the same time to transform like 1 billion objects into maybe a single number from each of those objects in like half a second. And then collect all of those numbers inside of, say, a summation or an averaging function. And you get a design pattern called MapReduce, which was studied heavily at Google and is probably how they do a lot of their data processing. So, sweet. Cool stuff. Pause for a second. Questions about this? Again, this code is this example code is available inside of the same repository. So in our JS Advanced Functions class repository, we've got a map. And here it is, the definition of map, an array of objects that we want to iterate through, and then a function that pulls out the first names from those objects to see how we can use map, right? So we've got example code there. And in case you guys had already read it and found it extremely confusing, as I did the first time I read it in this book, which wasn't really that long ago, he has the section on functional programming where I believe he actually implements for each. And so if you guys read through that and had a hard time understanding exactly what he was talking about, now you have a much stronger sense of what he's talking about. And if you reread that section, I bet you'll get it this time if you didn't get it the first time. So, cool. As part of our homework assignment for tonight, there are 3 higher order functions like map and for each that I want you to implement. Let's go ahead and have a look at that real quick so that I can see them. We'll come back to talk about homework towards the end of class as well. But you're going to create a select function which will extract items out of an array based on the fact that they meet a truth condition defined in your callback. You're going to implement a reject function which does the opposite. And then you're going to implement a find function which returns the first item in an array that matches a condition defined in your callback. So, but the pattern that you'll follow here in each case is going to be identical to how for each works. So you'll define a loop and then call a callback, check the result of that callback, and then do something with it, right? So, and there's only a few, and then you can look at the tests to see exactly how it works, but we'll talk about that more in a little bit. Okay. Sweetness. let's get a really quick 20-minute introduction to object-oriented programming before I turn it over to Adam. So. All right, and what I'm going off of now is, again, on OK Coders, JS object-oriented class. This is a very short document, intro object-oriented, certainly not comprehensive enough, but will give us what we need for the next part of our lecture. So far we've seen two ways of writing programs. We've seen what's called the imperative way of writing programs and the functional way of writing programs. In imperative programming, you give the computer a series of commands. So an imperative is a command, and you're basically saying do this, then do this, then do this, then do this. Yeah, just a list of instructions, a list of commands that it should execute. In functional programming, we're now organizing those commands into functions, and then we're encapsulating them into these reusable blocks of code that take variables and maybe other functions, and then we're calling the functions. And so in a real program, we would have hundreds of functions, and each one of our functions would be calling other functions and back and forth, and you'd have this complex control flow of functions, calling functions, and so on. Functional programming itself implements a couple of other cool patterns that JavaScript does not. So JavaScript is only partly functional, but just in terms of thinking in terms of functions, I think it's fair to call it functional programming. There's another way of doing things called object-oriented programming, in which you organize your code into related bits of data and then the functions that operate on that data. So right now what we've been doing is we call a function and we pass an array into it, right? And so our function and our data are separate. If we want to do something with the data, we've got some function over here and we give it that data. In object-oriented programming, our data and the functions are on the same unit. In fact, they're on an object, which is what we learned about a couple of lessons ago. And so we actually would have the array itself be an object, and then the map function would be something on the array. And every array has a map function. There is a wider, more abstract piece of code called the class, or the prototype, that implements map and sort of makes it available to every actual instance of an array. Yeah? And so now the data in the array and the stuff that we can do to that data goes together and is carried around in one object. And then we'll have objects that interact with other objects through functions. So basically objects call functions on other objects, which call functions on other objects, and so on. And then they will pass a little bit of data around, but largely they carry their data with them. So we're going to learn a very simple way of doing object-oriented programming that is not really how JavaScript does it. And then Adam is going to talk about how JavaScript really does it. So, as it turns out, object-oriented programming in either way is not really used all that much in Node, as far as I can tell. Node uses another way of encapsulating bits of code called the modules pattern. So it keeps things inside of modules, and we're going to learn about that once we learn about Node, which will probably happen on Wednesday. So. But it's super important to be introduced to this stuff, because if you do any other kind of JavaScript programming, this is how it's done. So, okay. I'm just going to keep working in this text document that I created here. Recall that we know about objects, right? So I can declare a person. A person is an object, say. Although you shouldn't objectify people. Did I already make that joke? Maybe.
Yeah.
And we know that an object is something in curly braces, and an object has properties, which are named bits of data, right? So my person could have a first name, Marky, and a last name, Mark, and an age, 33. I don't know how old Marky Mark is, but again, object in curly braces, property names as identifiers with a colon, and then whatever value they want to be. And they can be anything, right? They could be other objects, they could be arrays, they can be numbers, strings, booleans, whatever. We can stick anything that we want on an object. Now, we've also seen that we can add functions to our objects. Yeah, we can name functions that are associated with this object. So I could have a function called full name that I define like this. So identifier, again, the property name, colon, function, just like we're doing an anonymous function or creating a function variable. And then full name will return. And what I want it to do is I want to return first name plus a space plus a last name. How can I do that? I could hard code it. So I could say return Marky plus a space plus Mark. And that works. Then I could say var full name equals person dot call full name, right? It's a function. And then store that in my result, and then I could console.log full name. And we would expect to see Marky Mark when I do that. So I'll run my code. I get an error. Person.fullname has no method full name because it should have a capital there. Bingo, Marky Mark. Fantastic, right? Now what happens if I change the person's name? So remember, we can assign new values to the properties on our object. So I could say person.firstname equals, I don't know, David. Because apparently David is on my brain. All right, and now I'm going to call full name and log it. I think we should all know exactly what's going to happen here. It's still Marky Mark. My full name function does not reflect that change. Why doesn't it reflect that change? Because even though I'm changing the value of first name, I'm still using Marky and Mark. That's not really what I want to do, right? Really, inside of this function, what I want to do is refer to the first name and the last name. Okay? So let's just do that. Should be easy, right? I should be able to say first name plus space plus last name. Then let me go ahead and comment out that bit of code there. We can test it first of all to see if that works. Save it, run it. My program blows up. Return first name. First name is not defined at object.person.fullname on my JavaScript file, line 8, right? So I go over here and I go, okay, line 8, return first name. Well, it's definitely first name. So what's going on? What's the deal here? Yeah. So first name is not declared within this scope. So that's true. First name is only an identifier on person, right? It's not available anywhere else. The only way I can get to first name is by going through person. It doesn't exist in the global scope. I would have to say basically what I say down here, person.firstname, right? And so you think, well, okay, let me put person here. Person.firstname, person.lastname. That should work. That's a possible solution. Let's try it out. Okay, that seems to work, right? And I could change the first name on person, and now it's going to reflect it. Great, fantastic. But this is not an optimal solution. I could copy this person into a new person. And when I do that, it's going to copy first name, last name, age, and the function full name, right? And so let's say, and I don't have a, I don't know what the copy function in JavaScript is. Mayo, do you know what it is off the top of your head if I want to copy an object? No, neither do I, right? But let's just imagine that I've copied person into var second person equals, I'll say copy person. This is not actual code. That won't work. But you can imagine all this stuff has been copied. And then on second person, I change their first name to David, right? And now, instead of asking for the first person's full name, I ask for the second person's full name. What's going to happen here?
It's going to reference person.
Still going to reference person. I've still hard-coded something in here. Previously, I was hard-coding the name. Now I'm hard-coding the reference to this guy. So we still have a problem. This is not the optimal solution. Yeah?
The copy is just assigned first and second.
What's that?
So just take off the copy and friends and that's the copy. Just equal.
Oh, is there a JavaScript copy?
No, like on the line right before that, just take off the copy function.
Okay.
So for second person without first.
No, isn't that an assignment?
Yeah, but now you created another object.
But sorry, but isn't this by aren't these by reference? So it doesn't create another object.
Yeah, but once you say second person
Mm-hmm.
David, that's like second person. It has its own first name, but all the other properties are shared.
Are you sure?
Yeah. So like you can change second person first name.
No, see, it reflected David there, where I expected it to say Mark. Because it's still by reference underneath the hood. It doesn't actually make a copy of it. They're still pointing to the same underlying object.
Well,
you're still.
Oh, well, I'm asking for, no, but that's okay, because then I'm referring to person here, right? Whereas we haven't actually changed person's first name. Person's first name is still Mark. Does everybody see what's going on here?
Yeah.
So for that little bit of strangeness. So what I really want to do is like copy this thing, but I don't know. There's no built-in function that I'm aware of that does that. So we're just pretending that it does it. Okay. So what is the solution to this? I need a way of referring to the first name on whatever object is sort of currently being referenced, right? And so if I want it to be, what's up? So if you figure out a way to do copy, that would be great, because I'd love to demonstrate this. Like if I happen to have a second person, I want to refer to the first name on that one. And if I've got a first person or a 10th person or a 1,000th person, I want to refer to the first name on that one, not this person. How can I do that? Yeah, this is like the basic problem that, or one of the basic problems that object-oriented programming needs to solve. I've got objects. I want to orient what my functions do to the data on those objects, not the data on some other object, right? So how do I get access to the data on that object? JavaScript and many other programming languages have a special keyword that will refer to the context, as JavaScript calls it, or the object on which a function is being executed. And in JavaScript, that is the this keyword. So literally THIS, this. In some other programming languages, it's self. I think those are the two main ones. And so now instead of referring to person directly, I'm going to refer to this. And again, I'm going to do it over here. This. This gives me access to the object to which that function is associated. So this function is on this person object, so this will always refer to person. Well, I mean, under normal circumstances. And then if I were to make a copy over to a second person, this would refer to the second person instead of the first person, right? Which is pretty awesome. And that's called the context in JavaScript. The context is just the object that a function is being executed on, right? So I can run this to get an example of it. So let me get rid of that stuff. Actually, let me comment it out in case we can find a quick way to do a copy. Person, and so now I'm going to refer to person.fullname, and we'll see that this is a valid way of referring to the person's name. And I can change person.firstname, and that change gets reflected every time, right? So this, again, this refers to the object on which our function is executing. We can use this to refer to any property on this object. And we know that properties can be simple variables, like, or simple values, excuse me, some basic data, or other functions. So I could have another function here, and I'll just, let me just create a second object. I'll say var foo equals some object. And then I could say, let's have a function called bar and a function called baz. These are just like, they're called meta variables, stand-in identifiers. They're meaningless. But the point is, if I want to call baz from bar, I cannot just say baz. Baz refers to a function defined somewhere in the global scope, right? If I want to call baz on foo, I don't want to say foo.baz. I want to say this.baz, just like I can refer to any variable on it as well, right? Does that make sense? And so now what I can do is attach data to an object and then attach functions that do something with that data to the object and move them all together in one piece under the name of that object, right? And then as it turns out, as we're going to learn from Adam, you can create prototypes, or sort of like, they're called class, and they're not really called classes in JavaScript, but sort of like templates for objects, and then create many copies of those objects, and they'll all have the same functions and be able to deal with the same kinds of data. So then I could create 1,000 people, and they would all carry around what they do and what they do it to with them individually, right? And that's pretty awesome. And so we've actually already seen a couple of examples of this. from our previous homework assignments? Can anybody think of an example of us doing this already in some of our previous homework assignments? Dot length is a property. What was a function? Char@. Yes, perfect example. So if I have a string, and I'll just do this in Node. So and I have marky mark, and I'll go ahead and assign it to a variable. Right? So I've got name, marky mark, and I do name.char@, and I say 2. What is magical about this? I do not have to give char@ the name. Char@ already has whatever name is. It's on name. And so when it refers to the string that name is internally keeping track of, it's referring to it by way of this. Char@ is operating on this bit of data. Name is carrying around the data and the function with it. Yeah. Whereas in maybe a previous way of doing things in other programming languages like C, or if we were just writing functions, I would have to define a function char@, and my function would need to take two things, some string and some index. And then in that function, I would return string item at that index. Oop, and I got a spelling error there. So it won't work because, shoot, I have to get out of it. Let me rewrite that. Like that, right? And so what's the difference here? I have to define a function that takes the data, whereas this function is already associated with the data. And I can have as many strings as I want. So La La Land. And La La Land, what did I call it? Anybody remember? Second string? Yeah, I'm stuck in something too. Second name? Also has the char@ function built into it, right? So these are instances of strings. Each string keeps track of some underlying characters and offers a bunch of functionality with those characters. Every single thing that we use in JavaScript, number, Boolean, string, an array, an object itself, all behave like this. We have been doing object-oriented programming the entire time without really realizing it. And now we have a way to define our own objects and use those in our code, right? But the thing is, we're not really doing it the way JavaScript does it. For that, Adam is going to give the next hour worth of discussion. Any questions? We'll take a break before we get started. So,
is like, do you like choose functional or choose object oriented, or do you kind of implement both at the same time?
Some languages are exclusively one or the other. So there are functional languages that don't know how to do objects, but do similar things in a functional way. And then there are object-oriented languages that used to not be able to take, say, higher-order functions, and so they wouldn't support some of the patterns in functional programming. JavaScript supports both, but its primary means of doing those things is through functional programming patterns. And so as we'll sort of learn out, when you declare objects in JavaScript the right way, you're actually declaring functions that just behave in a particular manner. So JavaScript supports both, but really you're doing functional programming, which is why object-oriented programming in JavaScript is so bizarre, I think. So they all do the exact same thing in terms of, like, what are we trying to accomplish? We're trying to organize our code, basically. We're trying to find the best way to organize our code. And so there were a bunch of guys that came along and said functional programming is the best way to organize your code. And then there were a bunch of academics that came along and said, nope, object-oriented programming is the best way to organize your code. And either one or the other was in vogue for a period of time. Really, it depends on what you want to do with your code. I think if you're doing lots of data transformations and things like that, maybe functional is a better approach. But if you're trying to really model real-world objects like people and animals and things that people do to one another, an object-oriented approach might be better. In the end, you can do the same kind of stuff. You just have to approach it from a different perspective. So, and I think it's great to have a language that lets you do both. That way, you can choose what's appropriate for your situation. So. All right, one last thing, and then we'll take a 5-minute break. I've talked about context here. Don't confuse context with scope, right? They might sound a little bit similar, but they're different. So obviously, there are some similarities. Like context gives me a way to refer to things that aren't in scope. So you think, okay, one lets me fix the other. They're kind of related. Scope in JavaScript is always a collection of identifiers that are available to the code at that point. And identifiers is just names of variables and names of functions, right? That's all an identifier is. So scope refers to the set of all things that I can do in my code at some point, basically. Context refers specifically to a single object, and it's like an object in my code that is this whenever I run a function. And so that special keyword this, that thing will be the context. And the context itself will be some kind of object. And normally, the context of a function is the object on which that function is defined or on which that function is being called. Normally. We can change that and do some pretty magical jujitsu in JavaScript, but for practical purposes, that's how it works. And so that's the difference, right? Scope is the list of all the identifiers available at one point. Context is the single object that this represents. So don't get them confused. All right, 5-minute break. And then Adam will give his presentation. And we have more lollipops. If folks want lollipops, eat some lollipops.
Wait, this is what like you just say person and copies of it, right?
Right.
So like when you say person, second person still is this referring to the same person object? When you say second person, that first one equals new, then second person has its own.
That because but you got this here. Replace this with person.
Okay, but that's what I was saying. Like that won't work, but second person is referring to like once you do that.
Oh, it's got its own. Okay, so second person and first person have different names, but the function inside still refers to the first person's one.
Yeah,
gotcha.
And so do everything else except for the first name, because the only one thing I've changed is first name.
Okay. Oh wow. Okay, so like under the hood, it's being conservative in terms of allocating new space for resources. That's bizarre.
It's the same thing like if you say you create a constructor object and you new up an object, right?
Right.
It's basically just creating like a copy. Right, so all the functions that you had on the
are still refer to the exact same thing.
Yeah, it refer to the
until you redefine them or override them.
Yeah,
or whatever.
Exactly. So it's just basically gonna look at.
So bizarre.
Yeah, I know. So it's gonna look at the thing you've constructed, and if the function doesn't appear there, then it travels up the prototype chain.
Right.
And then
So it's the next one.
Yeah.
Okay. So that's.
Okay. So yeah, I misunderstood what you were saying there.
Yeah.
Okay. Cool. So remember, so we'll get you plugged in here. I mean, they don't brand new, right? Object-oriented programming. So if you use things like inheritance or classes or prototypes, they've never heard of them. So just take a sec to explain it. So.
Are you gonna use Vim?
Yeah.
So he's gonna use Vim.
That's okay.
He's a Vim and Tmux.
And I think you can probably draw a current from that guy. Okay.
Yeah, I probably can. I think.
Are you? You're not Retina. Yeah, it'll be about the same. Cool. I'll clean up the rest of this stuff off here too. And then the video plugin is right there. Oh, and I've got the Google Hangouts running on here. So.
Right.
How do I get this guy back onto?
Yeah.
Oh, wait, maybe I can just... Oh, sweet. Yeah, I'm sorry about the cabling is not the best, but
It's alright.
I don't know. Who knows exactly? It sounded like somebody wasn't showing.
That's in a desk.
People don't just do
I think that's
I have like in my head visual of what happens. Yeah, that's what I was like, oh, they just started like something.
Yeah, that's
I've actually been doing a lot of reading about templating. Templating in general.
Yeah, I'm not sure how.
yeah.
The weekend,
I know there was like
last weekend I went back to school and so have a 2 weeks course. Actually, I'm not a big fan of the sport, so I just went back, just enjoyable.
I don't know. We know where we're at. Yeah, we're good.
I'm on the bandwagon.
I think they started here.
You're watching?
And if I'm not like really watching that kind of
Soccer is very popular in China. I saw it was less popular in USA because everyone say here is soccer. You know, soccer is much more popular. Yeah.
I haven't.
Everyone's like, you're holding the parking lot. Oh no, I'm talking about like basically you would say that you're in front of your house. You can park here.
I know. That's why
That
I
was my interpretation of it. I didn't read into it because I don't need that. Are you serious?
Yeah,
I park, you know, I'm not near you. You wouldn't have to sit out there and sing songs.
Which soccer team is your favorite?
Well, you mean nation.
Yeah.
I don't know. I don't really want that.
basically
I guess because I don't know.
sell to whoever, they just wait.
Enjoy it.
Yeah.
They just leave. I can see the problem. If it's like public property.
Yeah, you see that. That was
All right, guys. So let's bring it back, and I'm going to keep the this guy in front of you just so that it can see the screen. Okay. Introduce yourself. I know Adam. You work in TM recognition.
Yes, I do.
Okay. And I guess do you do JavaScript programming for them, or?
Yeah, I do JavaScript a lot, and I also do C#, mostly web development these days. I just started. I'm from Salt Lake City, so I've only been here for like a month. So back there, I used to do kind of the same thing, C# mostly, and JavaScript. You know, really dynamic web pages and all that stuff with Angular. You guys probably won't know what that is, but hopefully you will, and hopefully you'll love it as much as I do. So, cool. Without further ado.
Yeah, take it away. Thanks, man.
Yeah. So we're going to go over prototypes. We're going to show you guys how to do some inheritance. It's pretty simple once you get the gist of it. There's some crazier things you can do, which you will probably never do if you get a job. Usually what you'll do is kind of stick with the basic stuff. It's more of an advanced into using. I'll go into some of the reasons why you should use it. And it's at 720p. I can't make it any smaller. Oh, I have to change the font size. Probably. I don't know if that'll work in iTerm because there's pension plus.
Yes.
Try.
Command Shift plus. Oh, it does work in iTerm. Never mind, you guys saved me. Okay. Alright, it's a little better, maybe bigger. Alright, so here we kind of have the same kind of example that Phil's going over. We have person 1, person 2. If you want to have, like, let's name this guy Steve. Okay, and Stevie. So obviously, like, an efficient way to go about making a basically a container of code that you could reuse to have a person. You know, you have to copy paste this over and over, and the other thing too is down here I have this code. So if I say no, I think it's file yes. See, it's false. What that means is the full name function isn't equal to the full name function of person 1. So what does that mean? That means that they're two separate objects, right? And let's say you had 1,000 persons. That's 1,000 different functions you're declaring, so that's a waste of memory. The one thing that is cool about prototypes and inheriting properties from other objects is they share memory. They share the same function, and so let's say you had 1 million of them and you're running in someone's computer and it crashes. Obviously that sucks. It's a bad experience for the user. You want to stay away from that. So let's say we instead did something like we have person 1 here, and we make this a function. What this is going to do instead is, this is what is kind of known as a constructor. Let's just delete some of these properties and make it a little faster. So a constructor is an object that sets up the state or the values on the end properties on an object for you before you start using it, right? So the idea is your constructor is supposed to always build up your object and put it in this known state so you can start working with it and nothing else. And so what we have here is we turn this into a constructor, and let's name this person now. Let's just get rid of this for now. So obviously if you call this, we're not returning anything. So this isn't going to return a value if we just call it directly. We can just do that right now just so you guys can see. We get undefined, right? It's not returning anything. So it's like, well, how are we going to build a person with this? And so that's when you get introduced to the new keyword, right? And so what the new keyword does is it's basically a shortcut, if you will, an operator, kind of like plus or minus, to just create to treat this function as a constructor function. And so what new really does behind the scenes is does 4 things. And so if we just run this too before I go any further, we obviously get an object back. So what the heck? It's not returning anything. Why is this returning an object? So the first thing that new does 4 things. Okay, just to get it out of the way. So what new does is first it creates an object, and obviously you guys, I think you guys have been introduced to object literals. Have you talked to them about that? Like an object. Well, I guess you wouldn't know what that name is, but
Yes.
yeah. Okay, so
Basically, object without a variable.
yeah, basically like your 2 brain properties. New does that first step. Then second step, what it does is it sets the constructor property. There's a hidden constructor property on every object that participates in prototypical inheritance, right? That's the huge buzz phrase. But basically what happens is it sets that constructor property to this function, right? So what that means is now it knows, it gives it a piece of data that lets everyone know what type it is, where did it come from, right? So this function now it's carrying it, and that's how you know who made this, is with this constructor function. And so the third thing it does is there's also another property called the prototype, and it sets that to expect that you're calling, like it sets it to that, no, we'll get into that a little bit later. I don't want to get ahead of myself. Just, it sets a prototype function, okay? And put that on the back burner. So the fourth thing it does is it now calls this function, and I don't know if you guys have been taught the apply stuff. Was that today? No? Okay. Well, it's going to be a little hard, but basically it's going to call this function in the context of that new object, and so that's what the this is pointing at. It makes the this point at that new empty object. So anytime you do this dot name, this dot first name, you're setting properties on that empty object, and you're constructing it, if you will. Right? Does that make sense, everyone? So, yeah. So back to this. Let's show this. So we have our new person. Let's break this out into a ring. We'll have so, which is the function that we had originally just constructed our object with. There's also, now I remember I said there's this thing called a prototype on this guy, and so that is what kind of defines, it's not on this object, there's an, I gotta get ahead of myself here, this is kind of complicated for me. So we have this person. Let's go ahead and make a more, how do you say this, a more specialized version. Let's say Mark is more specialized, or Steve is more specialized than Mark, right? Steve's better, faster, and stronger, and he's not 33 years old. So let's say super person equals function, and let's go ahead and say that this person's first name is now Steve, right? And we're just going to set, oh yeah, we need to set this. No one caught that, you guys are bad students. Last name here, because this full name function would fail. Let's just call him Marky again. There we go. So we're going to have first name Steve, last name, we're going to have Doe. And then we're just going to, how about that? That's it. Let's just leave him, 33 for now. So obviously if we change this, let's say we call age here, and we name this, or we change this to a super person, right? So what's going to happen here, we're going to probably see undefined, right? And so obviously that makes sense. We didn't construct our object with an age property, right? But we want to reuse the age property on the other person. So here's where the prototyping comes in. There's this, on every function there is this property called prototype. And so if we go superperson.prototype equals new person, right? Let's run this. Okay, So let's back up a little bit. Now remember I said on step 3, it looks at the object's prototype and sets it when you call new. So what that does is it delegates all the function calls that don't map to the properties of the object that you're constructing to the prototype chain. And so the prototype chain is basically a chain of objects that the JavaScript VM searches down to find properties that aren't on the object that you're calling. So at the head of our prototype chain, we have person1, which is a super person, right? And what happens is when you call new, it's going to go in and say, oh, you set the prototype to this other function, so I'm going to new up this function and set the underscore, the super hidden field. Don't rely on this. Don't ever really try to call this in like actual working code because it doesn't work in all browsers. The only one I know that works in is Chrome. Might not. It definitely doesn't work in IE because nothing works in IE. But so as you'll probably soon find out. But this right here, I don't know if this is a node. Let's give it a shot. Yeah. So here, let me just shoot this down. So the underscore proto secret field, basically it news up that person when it goes to, here, let me just back up. Gotta make this, gotta go slow. This is kind of going to be a mind bender. So when you set the prototype of a function and you new up that function to return a new object, what it does is when it goes down and starts building up the prototype chain for you, it looks at the prototype, that function. Like it's hidden, its prototype field here. It to that and does the same thing and builds up this chain for you. And so when I call, let's say, you know, any property on here that's missing on the function you're constructing at your first new call. So here we don't have an age. It's going to look at this object and go, hey, do you have an age property? No. Next one, next one, next one, until it finally finds one. Okay, if none of them find. All right, does that make sense? So basically, new is a kind of shorthand way to say new superperson, and then say person1.proto equals new person, and then do that continually until your inheritance tree or your inheritance chain is built up. Right? That makes sense. So now we're all on the same page. Now what does this mean? This means that we share everything that this object declares and every other object before it. And so before, now this should work, we go var person2 equals new person. Let's see. Was not expecting that. We'll get to that later. So basically, they do share the same function definition. You want to do this because it's going to save you lots of memory. The idea is like, instead of you making a new function definition in this guy, and then there's two, what's going to happen is it's going to just make one, and then everything's going to point at that one, right? Instead of you making two people and defining first name twice, you're just going to have one. And the other cool thing, now let's go back a little bit. This is probably why it didn't work. So this prototype right here is a live object, and what the live object means is if you edit the prototype object, you get all the changes down the tree. So what does this mean? Basically, this means, let's go ahead and delete this. We have our person1 prototype, or superperson.prototype. Let's print out here. What we can do is say super person dot age equals, let's say, let's make him 12. And then here, we need 2 of these. We're going to say person 1 dot age and person 1 dot age. Okay, I got a little bit ahead of myself. Okay, so this is what I expect to happen. So what happens is it builds up that prototype chain for you. So what that means with this being a live object is it's going to look up the value of this object here, because we're newing it up and putting a live object in here. You can just fiddle with it all you want, and it's going to change this. So it's going to always look this up as you call it. So what you end up getting is, can you guys not see that? Those. Okay, my bad. So what you get is 33 before we changed it, right? We changed it to 12, and then we printed the same thing again to get, right? So with that said, you could, everything that inherits from you could have this new up this person, and let's say have superperson 1, superperson 2, superperson 3, and if they're all the prototypes are pointing at the same object instance, you could change it, and then boom, everyone gets the same changes, right? So it's not, think of it as, you know, it's a chain, and there's these links in the chain, and you're just grabbing junk from. Yeah, it's dynamic. So as you call, then it figures it out. That's pretty much the gist. Kind of hard to wrap your head around on your own, but, and plus you guys aren't coming from like a background with classes and all that other stuff, methods and things, so you guys are going to have an easier time getting it. So that's basically the gist of it. And me being a professional developer, you don't typically, you could get away with never using prototypes, to be totally honest, in like a production setting where you're building professional code for people. And I mean, there are some times when you should use it. Typically in the JavaScript world, they're going to be more functional, and functional. One of the strengths of being functional is you get these really sweet object literals where you can define your properties in those and deal with those only, and not have to deal with you know, inheritance and all those other things. As you guys learn other languages, hopefully you guys do continue on learning. You'll see how you know, this kind of is more dynamic, and other languages are far more static in this way. So, but if anyone has any questions, feel free to ask. Guys, if you guys are like deer in the headlights. What's up?
So if I create a constructor object that has a full name function.
Oh, yes.
And then I create two new objects from that. Do each of those have a copy of the function?
So, okay, so what you're saying is I take this person function with this full name, and then this guy, and I make a new function of the same name? Is that what you're saying?
No.
What are you saying?
So this new, two new, person objects.
Okay, okay, I see what you're saying, person, right?
So now there's person 1 and person.
Yeah.
And person 2. Those two have their own copies of that full name function.
They have their own copies. As in, if I double equal these and I console log it, will it be true or false?
So like if you print out the person 1 object, it's like console log. Will full name be on there as a property?
Oh, I see. Let's just run it and see. Let's just clean this up. So we have full name function, right?
So is that full name on the person, or is it on?
Yeah, it's on the object that gets. I get we're getting that now. So it's on the So remember, new calls function in the context of a new object, right? Does those 4 things. And then, final step, it calls this function and it makes the this point at that object. So, yes, they should be the same, exact same. I don't see how they could be different.
You draw it out.
We draw it out on the whiteboard. I think it's just being a pain. Okay, let's see. Give it a shot here. Just gonna kill all this stuff. Hopefully no one runs. Sure, that's good. Now, if you get, yeah, I know, right? So if you guys have any input, Phil, if you have any input on prototype stuff, then be welcome to just like correct me if I'm wrong.
Yeah, I mean, it confuses me.
It's hard to wrap my head around, so you're gonna end up Googling stuff most of the time. But okay, so what am I writing here for you? So I'm writing our var person. A var person. Function. Okay. So we have our function. Right. And so we remember what the body of this was, right? We're returning this stuff. Okay, so when you new this up, person 1. What's this doing? So first you get this object here, and we'll just make it this squiggly, and it has a prototype chain. So it's going to look up proto, but we haven't set the prototype on this object, so it's not going to be pointing at anything. So when you go to call this full name on person 1, it's going to be this function here. So if we have var person 2, all that, it's going to be the same thing. So I guess they're their own functions. They're not actually like the same, but they do. I did read somewhere that they save memory, right?
I was trying to ask questions that I made a website. But really, person 1 and person 2 don't actually have a copy of that. They just reference it. So what's on that person object? Their full name. And when it doesn't find it on person 1 or person 2, it'll look up the prototype chain to parse it, the original constructor.
Okay, this is going to be pointing at this guy because the constructor property got set because of new, right? So
it's not allocating
yeah, for functions anyway. I don't know about properties. I don't think that's true for properties because they're not objects. They're just string. Those are different. Those are like native types. Don't even do that later. But yeah, the functions.
To the constructor. Can you create a constructor?
Oh yeah, you definitely can. Like instead, let's say this age here. What am I doing? Let's really just type this out. Oh, right. So I became a programmer. Yeah, you can totally take in parameters, and it's parameterized constructor is the fancy phrase. So let's say we have taken the age here, and we want to set our age to age. So here we have. Okay, so super person prototype. And let's say all super people are 10 years old, because that's really cool. Young kids. So we have news super person. So you get 10. Oh, never mind. Did I? Okay. It's Venice freaks you out.
Yeah, I just saw the last one up at the starting link.
Yeah, so you can override, you can, set properties in here. There's a lot of ways to do this kind of thing. You just set the prototype and do it. You can override it, and you can do, you know what I mean? You guys see that? We could just say this.age equals 10 instead of having to pass it in here. Yeah.
So right after this, so after is that your console.log, the bottom one there.
Yeah.
If you were to then change the age like you did last time, the line off it is where you had superperson.prototype.age. That's how you changed it in the first example.
Oh yes. Okay. So.
Could you just kind of explain?
Yeah. So the underscore. Remember I told you guys about the underscore proto. That's pointing at the object that this thing is going to look up. Like that is basically the prototype chain. That thing. And it's like the data structure in program is called a linked list. It's like a linked list where one object points at another object, that points at another object, and you walk down the links, right, to get at each value. It's basically like an array, except you don't access the indexes. You go through each link. It's like that. So this person .age is going to walk down the link until it finds one that has been defined. Does that answer your question?
Yeah.
Okay. So if we go and set that, it's a live object, and what that means is the underscore proto. I knew this thing up here. So this is a new object that is put in here, and when you call new, it takes this and puts it in the underscore proto. So if you change this guy, it's going to walk down the links, and then all your changes that you made, it's the same thing. Trying to apply those changes, right? So
it's kind of like a dangerous thing to do.
It is. It's JavaScript. There's lots of dangerous things you can do. I mean, you can even go far. Oh, so here's one thing that is. Now, I gotta show you this. Just remember this. So we have our super person. There's this keyword called instance of.
Yeah.
So instance of, let's see, super person. So that is the only kind of notion of types in JavaScript. It knows that this object was constructed from this function that's set in this variable super person, right? It knows that they're the same. And how does it do that? Well, it does. It looks at the dot constructor, which is going to be our function, right? And so what you're saying is, well, that's kind of dangerous. All these things are out in the open for you. Just hang them loose. You can change them all you want. What will happen? What would happen if I changed it? Well, this guy, you can set it all you want, but it's not going to set. It's going to set it over top of it, and there will always be a dot constructor that instance of checks. So you can set it. It'll look like. But no matter what, your instance of is always going to work. So you can set things over the top of this constructor function, but it will never actually be changed. When you do instance of checks, it will always be type it came from. So, like if you wanted to see if a property was a function on an object, instance of function with a capital F. So let's say, for example, if you wanted to make a function that can work with multiple different types of arguments. Let's say it could take a number, or if you don't pass it a number, you pass it a function instead. It calls it. Let's say you could check the type with instance of to see what kind it is. Was it constructed with a function constructor, or was it constructed with a number constructor? So
Can you demonstrate that?
I can. Let's see. Let's say person1 full name instance of function. So, oh yeah, let me just clear up some of this stuff here. So we can see that full name is an instance of a function. If we scroll up here, it's obviously a function. So that is actually how functions are made. They're just objects, right? But they're constructed, and the function is, in its prototype, it has a bunch of extra functions on it that you can call. One of them is apply, so you can call a function with different contexts and other things that we'll get into later. You can even get, the number of arguments it takes. So let's a little bit of wizardry. It's maybe a little bit crazy, but I think it's .args. .args. Okay, it's not .args. No. What? Is this just arguments? Okay, so because it's null because there's none. Does it take any? If I change it, will it change? We're going on a little adventure, guys. Hope you don't mind. Yeah, that should be good. It's not the arguments. I think you're just trying to make it like a fool up here, man. Okay, so yeah, there's a bunch of different properties on there. So if you guys want to explore what different kinds of functions are on these different objects, it's actually probably way easier if you just open up Chrome. Let's just go to some GitHub repo here. It's taking a little while. Okay, so oh wait, I gotta open up Chrome. This would be a pretty good thing to check out. Chrome's a lot more fun to play around with JavaScript in because it has like IntelliSense and stuff. So you can actually see all the different types of things on objects that are actually having to, do a whole lot of work. Let's say hello equals function. So you have like a ton. It's like showing me what I can actually type. So if I go hello, it prints out like the source. Hello. So we have apply arguments. It is arguments. I don't know what's going on. Oh, maybe it's a function. I don't know. Okay, it's not. But there's tons of different things on it. You guys can play around with it. So like here's the prototype. There is prototype of. Like there's tons of different things you can look at just to play around with it to see if you guys want to do some exploration on your own time. This is by no means you have to do it, but this is like one of the. This is why I like building websites for Chrome so much because the tools are really awesome like this, as you guys will probably find later on. But any questions?
Unique instance of using functions to the times or
the constructor. Yeah, basically.
It's looking for something.
Yeah, I was looking at the constructor field that is set by the new call, the new operator. So if you don't new up an object, you don't get that kind of type checking. But it does, I believe they all are just objects. The prototype of everything is an object at the end of the day. like the very end of the chain.
But do you need that to you need the yeah, I mean, what, that's what is that?
It's a keyword. It's operator, yeah, just like a plus or a minus. It just, operators are basically just shorthand ways of doing things, like adding two things together. Think of it as like, I don't want to like go too far ahead of myself, but just think of operators as functions. It's just like it takes one thing, it takes another thing, and does some operation on it, and gives you a result.
So it's an easier way to go about it.
Right. So like the new operator does those four things I described. It makes a new object, sets up the prototype chain, sets a constructor property, and then executes that function in the context of that new object you created. So in the same way, that instance of compares the constructor function with that function that you're asking, is this an instance of this function? In the same way that the plus operator takes a number, or takes two things and adds them together. So, yeah. Does that make sense, guys? Take a look. If I missed anything, it's my first time actually teaching, so please forgive me if I haven't covered anything. Please ask me if you have any questions. I'll try to go over it again.
Did you go through this whole thing again?
I probably could, but I don't want to.
So does this mean that you can create a function by newing one up?
Yes, you can. You can. In fact, that's pretty much how the function keyword works. I'm not entirely sure how that would go because I've never tried doing that. Because it seems really crazy to try to do that. But I'm sure you could. I'm sure you'll probably Google it some more and then show everyone how to do that. All right, let's do it. Var function my function is a new function. Am I supposed to give it arguments? I don't know how it does it. It's magic. But I'm sure if you Google somewhere, someone has asked this question on Stack Overflow, and then there's an answer showing you how to do it. This crazy way that you should never do if you figure it out. Never do that. Because if you work with me, I'll kill you. If you do that in production code, don't do that. So, but anyway, any questions? Any things you want to try? Any crazy stuff? Nope. That's all I got.
Cool. Thanks, man.
Yep. No problem, dude.
Call me Marky Mark.
Marky Mark.
Yeah, right.
He is 33, so. Alright.
Cool. So that stuff is hard, right?
It's hard for me. It's crazy once you get in the thick of it.
But I think Adam is right, though. You can totally get away with without having to use prototypes too often in your own code. What you will see, and what you'll almost certainly see in the libraries that we use, is that sometimes you'll want to use that new keyword. So you're going to create a new instance of something, and what that is doing is just creating a copy of a particular template of an object and giving you access to all of the functionality of that object, right? Because we saw that a little bit earlier, like when we had arrays, we could say new array instead of saying array with the empty brackets, right? That's all that's doing. There is syntactic sugar in JavaScript that lets us create a new array effectively by assigning a variable to the empty brackets, and then it gives us all of the underlying functionality with it. I think the big takeaway here, though, is that we have this ability to encapsulate data and stuff that operates on that data inside of an object, as in the guise of one of these functions, and then you can have a hierarchy of objects that share some of the functionality of sort of higher up objects, and then implement some of their own functionality as well. And we will see a little bit of that in the code that we use as we're going forward with Node and Express. But like I said, a lot of what we end up using is modules that organize code a little bit differently. We're going to learn how to do that on Wednesday. Any questions in general about the lesson?
Could you, would this be something I could use for a particular animation, for example, spike animations, as you know, to make it animate?
Yeah, sure. Yeah, I think you could totally encapsulate what constitute an animation inside of an object. So say you had an animation object, and you had maybe like 5 points at which you wanted the animation to do something in general. So like the location that it should be at and how it should get there. And you could encapsulate that with data and then point it at some page on the HTML. So that could be another data property. And then you would actually have the function animate that would go through the data that you specified and do that thing to that piece of HTML. So yeah, you can use functions like this. You can use objects like this anytime you want to grab a bunch of data, stick it together, and then grab a bunch of functions and stick it together with that, right? That's what this stuff lets you accomplish. So, and I think, really the easy way to think about this stuff is when you're modeling real-world objects rather than abstract concepts. Person. A person has a name. A person has an age. A person has a place that they were born. Things that you might want to do to a person, add a friend. So the person could have an array of friends. Now you want to add a friend, and so you pass a friend or another person to that that function, add a friend, and then internally it goes this dot friends at the last index equals whatever, and so you've added a friend to that person. So stuff like that. We're going to see that once we start working with the databases, because we're going to have like a blog post, and our blog post will have some properties, but it'll also have comments, and we might want to add a comment to our blog post, and so we might have a function like add comment that encapsulates the underlying implementation of attaching a comment to a blog post. So. Let me plug my computer back in real quick, and I'm going to show you guys our homework assignment for this evening, which we want to have done by Wednesday. We have, I already kind of mentioned it a little bit, and so people who are watching online, bear with me for a moment as we look at our homework. So check out OK Coders, JS object-oriented homework. We've got 2 assignments, higher order. We actually have 3 assignments, higher order.js and objects.js. Okay, and so you'll go in there. It's going to work like all of our code before. Some instructions, implement the function, and then there's some tests that run it to make sure it works correctly. If you run it against the console, node.whatever, the tests fail. Write the code until you get the tests to pass. Same with objects.js. So practice using functions with objects in this, although not in the more advanced prototype system, but just the stuff that we were talking about earlier. Mostly I want you to get used to the idea of using this to access local properties, or properties on the object, rather. And then again, tests that check to see if everything's correct. And then, what is different today about previous homework assignments that we've had with JavaScript, I also want you to create a new Express application, like we had been doing the first couple of weeks of class. I want you to add Twitter Bootstrap templating to that application, and this is all mentioned in the homework assignment here. So, 1, do the assignments. 2, create a Heroku homework site. You should then, so you've got Twitter Bootstrap styling. Create 2 files in that public directory, right? Functions.html, or whatever you want to call it, higher order.html, and objects.html. And then I want you to copy and paste your solutions to the assignment into those web pages, so that you can see them on a web page. The whole point of this is just to practice using Express, Git, Heroku, and all of that again, because that is what we are going to be doing from this point on. And so I want to jog your memory before we get into that on Wednesday. And I've given you an example of what I'm talking about. So imagine I created an Express application. So I made a directory, cd into the directory, type Express, it adds a whole bunch of files. I go and I create inside of my public directory example.html or whatever. I add all of that Twitter Bootstrap templating. I fix my links and scripts and stuff to handle everything correctly. And then I want to show the implementation of the select function. And so I wrap it inside of this pre-tag. And then I want to show an example of its usage, and I do the same thing. I'm basically making a pre-tag, and then I'm just pasting that JavaScript literally in there. And that JavaScript will not execute as JavaScript because it's not in a script tag. Instead, it's just going to show up in the page, right? and it'll end up looking something like that. Right? So I've got the Twitter Bootstrap styling. I can see the code that I've written, and it just shows up my implementation for select, my implementation for usage. You could have another one for filter, another one for whatever. The only point of this is to just get in the practice of creating a web application with Express again, using Twitter Bootstrap, using Git, and uploading all of that to Heroku. Because, again, that's what we're going to be doing from this point on. So. Is that clear? Don't execute your JavaScript in the code. Just get it to show up in there. And on the homework assignment, I've referred to the previous lessons where we were using that material quite a bit. So here's a reference to our Git Bash and Heroku repository for the class material, and then the Bootstrap repository in case you need the refresher. Cool. Any questions? Wednesday. Let's figure out how this stuff works that we've been using the whole time. All right. Thanks, guys. Sweet. And thank you, Adam, again for coming and talking about the prototype chain. And